Okay, this is the Vulcan way. Today we're doing solving equations and inequalities, and if you use the same book as we do, it's P7, P8. So we're going to go ahead and get started. So I've got some notes up here just to start with, so you'll probably have to pause the video and copy as necessary. But first of all, whenever you're solving an equation, if the variable drops out and you get something like 5 equals 5, which is true, 5 does equal 5, then it's all real solutions. It doesn't matter what value of x you have, the left side of the equal sign will always equal the right side. However, if you get a statement where the variable drops out and then you get something like -1 equals 4, which is false, then there will be no real solutions. No value of x will make the left side equal the right side. So let me see if I can adjust this light just real quick. It's a little better. Okay, so first example 1 says solve and state the restrictions. So this is a rational equation or a ratio equation. So we need to be able to solve it. So the first thing that you're going to want to do is factor your denominators. So this is where we practice simplifying and factoring rational expressions. So first thing you're going to want to do is this. And now most kids, because of how they've been taught to add and subtract fractions, want to get common denominators, which will work. It just takes more time and isn't as efficient as doing this right here. So what you're going to want to do is look at your equations. This left side has to equal the right side, and what we don't like about this is that there are fractions. So how can I make this x plus 3 cancel out? Well, if I put the same thing in the numerator, then it will have common factors. So that's what I'm going to do. And what I do to one side, I have to do to the other side. And then what will make the x minus 2 cancel out? Oh, put it in the numerator. So I'm multiplying by the least common denominator instead of getting common denominators. And then what happens is in math, when we have two terms and we're multiplying, we have to distribute. So in this first fraction, the x plus 3's will cancel out, and I'll have 6 times x minus 2 minus, and in this one, I'm going to have 5 times x plus 3, because the x minus 2's will cancel. And so fantastic, when I do it to this side, there's only one fraction, so I only have to multiply. I don't have to distribute. Those will cancel out, and I get -20. And now it's an equation that we don't mind working with. So what we get is 6x minus 12 minus, now you're going to be careful because that -5 is going to both. So we get 5x minus 15 and then equals -20. Then we combine like terms on one side. 6x minus 5x is x, -12 and -15 is -27. And then we're going to add 27 to both sides, and we get x equals 7. So this does say solve and state the restrictions, so this is just a review of yesterday's lesson. We get x cannot equal -3 or 2 because those are the values of x that will make the denominator 0. There's no dividing by 0 in math. So x equals 7 is a valid solution because it's not one of our excluded ones. If we, for example, got x equals 2, then our answer to this would be no solution because 2 has been excluded. We didn't get that, so we're fine. X equals 7 is the solution. That's how you solve a rational equation. Next, absolute value. You're going to isolate the absolute value and then split it up using the definition of absolute value. So let me show you what that looks like. First, I'm going to add 20. So I'm going to isolate this and follow it just as if it was a variable. So for example, if this said 4y minus 20, and I want to isolate y, I would add 20 first. Since I'm isolating the absolute value, that's what I'm going to do first as well. Then I'm going to divide both sides by 4. So I get the absolute value of 1 minus 2x equals 5. And then this is where I probably differ from your previous teachers because there is a definition of absolute value that you should be aware of. So most teachers at this point just tell you split it up and make one positive and one negative, which kind of loses the definition of absolute value. We'll get the same thing. You can use that method. There's nothing wrong with it, but what I want you to just focus on is absolute value, which is what we have right here. Whatever's in here, if it's positive, it stays positive, and whatever's in here, if it's negative, it also becomes positive. So both of these are equaling positive 5, but what we're really having is the positive case equals 5, and the negative case also equals 5. So whereas you've been told all along to just make one positive and one negative, it's not really this 5 that's generating the negative, it's the absolute value. Why do teachers tell you to do that? Because the very next step on this side, you'll have 1 minus 2x equals 5 in the positive case, and then you have 1 minus 2x equals negative 5. So essentially you're skipping this step, but I don't always like to do that because then you don't like use the definition of absolute value. You're fine. You can go from here to here. I just wanted to put in my 2 cents with that. So then you're going to solve each one. Negative 2x equals, on this side we're going to subtract 1, so we would get 4, so we get x equals negative 2, and then on this one we get negative 2x equals negative 6, so we get x equals 3. There's no exclusions because there's no division, so we get x equals negative 2 and 3. So once again, example 1, rational equations. Example 2, absolute values. Example 3, 4, and 5, and 6 are all the different ways you can solve quadratic. So first of all, quadratic is anything squared. It's weird that they call it a quadratic when it's squared because you would think it was something to do with 4, but it's not. It's a square. So the 4 different ways that we have is to factor. So this is our preferred method. It's the fastest method. Square root method, which we'll see in example 4. Completing the square, and the quadratic formula. Quadratic formula will always work. So if you forget any of these, this is your fallback. Just be careful on your test to make sure you follow the directions. So if it says solve by completing the square, you have to show completing the square. If you do it by quadratic formula, make sure you work backwards using completing the square, otherwise you don't get credit. So on this one right here, now we have an equal 0, so we can solve this as opposed to P5 when we didn't have equal 0 and all we could do is factor. So we are going to factor, and then we're going to set each piece equal to 0. It only works with 0. That's called the zero product property. Anything times 0 is 0. So when you're multiplying, either 3x equals 0, or actually, if you prefer, this might make it easier for you to understand. You can divide out that constant. We'll get the same answer. That's the beauty of math, is there's lots of different ways to manipulate your equations. And then we can do x equals 0 and x minus 3 equals 0. So we get x equals 0, and then add 3, and x equals 3. So in concise form, we have 0, 3. Typical math form is to put this in order from least to greatest. If you don't do that, you won't be marked wrong, but it's nice to get in that habit. This next one here says 2x squared plus x equals 1. Whenever you're solving quadratics, the best thing to do that works for almost all methods is to get one side equal to 0. And then because we have 3 terms here, we're going to try and t-chart this. So, or factor the trinomial using whatever method you're comfortable with. And in this case, this is what it will look like. So this, another way to write 2x squared plus x minus 1 is to do 2x minus 1 times x plus 1. Remember, if I reversed that procedure and multiplied it out, I better get the same thing that I'm starting with. I'm just choosing to write it in an easier way for me to solve. And then I'm going to set each piece equal to 0. And then I get 2x equals 1, or x equals 1/2. And then here I get x equals negative 1. So in order from least to greatest, writing it in concise form, I get that right there. Okay, so obviously I could solve this by quadratic formula as well, and we'll do one in a minute about that. but just know that's your fallback method, but there are more efficient ways in certain problems. So now we're going to go up here to solving by the square root method, which is number 2 written down below. And I will tell you that there's other ways to do this by factoring, and or you can, if you can't do it by factoring, you can do it by quadratic formula. So I have alternate way written up here just so that you could see you get to this point right here. 14, 7, and 2, that's not going to give you 10, so you would have to use the quadratic formula. But there's such an easier way. This is a perfect square. So if I gave you something like x squared equals 11, then you wouldn't try and mess with quadratic formula. You would just do that and get plus or minus root 11. And we're going to do the same thing here. We're going to square root both sides, and we get x plus 5 equals plus or minus square root 11. Just a little note about square roots. You only do plus or minuses when you didn't start with the square root in the problem. So in this problem, there was no square root. In order to solve it, I drew in a square root, so then I do plus or minus. If the square root is already there, mathematicians have agreed that that just means the positive case, and you don't need to draw in the plus or minus. But in this problem right here, I haven't solved for x yet, so I'm going to subtract 5 from both sides, and it's just proper form usually to put the negative 5 in front instead of the end. And I can't simplify that anymore. So there are my 2 solutions. And you may be thinking 2, remember that that means negative 5 plus root 11, which, by the way, I could approximate this number. Square root 11 is between square root of 9 and square root of 16. So it's somewhere between 3 and 4, and it looks like it's a little closer to the 3 side. So think of it as like a negative 5 plus 3.1. Now we don't have to do that right now, but I was just reminding you of some of the cool things that you can do in math to approximate. If you had to graph this for some reason, then you can just use that method. So again, there's 2 solutions, the positive case and the negative case, and you'll hear me say this over and over again, that mathematicians are notoriously lazy, and so they come up with shorthand ways to write things, like right here, they are writing negative 5 plus or minus square root 11. Notice the conjugates because they don't want to do that and write it twice. Okay, next example 5 is by completing the square. This is one of my favorite methods, but some kids just don't like it, and there's obviously a time when I choose to use it and when I'm like, nope, it's easier for me to do quadratic formula. So with completing the square, what you're looking for are perfect square trinomials. So what I mean by this is if we go up here and look at x plus 5 quantity squared, if I were to rewrite it in standard form, I would get x squared plus 10x plus 25. This is a perfect square trinomial because when I write it in factored form, it's one term or one binomial times itself, so it's a perfect square. All perfect square trinomials, this term right here will be half of the middle term squared. So half of 10 is 5, and 5 squared is 25. So when I look at this problem and I say, I'm going to complete the square, is this a perfect square trinomial? No, because half of 4 is 2, and 2 squared is 4, not negative 1. So how do I solve by completing the square then? Well, what I'm going to do is move that negative 1 to the other side. So I would have to add 1 to both sides. This c term, which I'm going to add to both sides to keep the equality true, is going to be b over 2 squared. So half of 4, which is 2, and 2 squared is 4. So that goes there and that goes there. So now what I'm going to do is factor this. So I'm going to use a t-chart. I'm not going to do it because I already know. I just set that up to be a perfect square. So it's x plus 2 quantity squared. What you can note is before you square in this b over 2 squared, that number right there is b over 2. So up here, b divided by 2 is 5, and notice what's in the parentheses is positive 5. So that always works out, equals 5, and then I square root, and I get x plus 2 equals plus or minus root 5. So x equals negative 2 plus or minus root 5. And those are my two solutions for that, and I did complete the square. I prefer to complete the square whenever there is no leading coefficient other than 1. In fact, that's a requirement for completing the square, which we'll see how to handle that in a moment. And whenever the middle term is even. The reason why I like middle terms even, because I know I'm going to have to do b divided by 2, and if it's an odd, I automatically get a fraction, which we'll see in example B. So, speaking of example B, first of all, I have 2x squared plus 9x plus 14 equals 0. I have this little note here. When completing the square, the leading coefficient must be 1. If it's not, then you have to multiply both sides by the reciprocal of the leading coefficient. So our leading coefficient is 2. So you can just divide both sides by 2, but I like you guys to get in the habit of seeing dividing and multiplying by the reciprocal are pretty similar. I mean, they're the same. So when I do this, I get x squared, because 1/2 times 2, they cancel out, plus 9/2 x plus 7 equals 0, because 1/2 times 0 is still 0. So the next thing I'm going to do is realize that this 7 is not making this a perfect square trinomial. So what do? X squared plus 9 over 2x plus blank equals negative 7 plus blank. So I have to figure out what this blank is, and I'm just going to put a little asterisk right here because we're going to do the math for that right here. Why? Because it's fractions within fractions, and we don't like it, but we can handle it. So first thing we have is b. Our b term is right here. It's 9 over 2. So we're going to do 9 over 2 divided by 2, because b is 9 over 2. And then we have to square it. Well, dividing fractions that you see, you got to multiply, copy dot flip. That didn't make sense. Dividing fractions, easy as pie, just flip the second and multiply. So this is what I have to do. I have to do 9/2, and this is really 2 over 1, and I need to flip it. So then I get 9/4 squared, which is 81 over 16. So all of that to find b over 2. So up here is 81 over 16 and 81 over 16. And then you're like, yuck, I don't want to have to do all that math. Well, first of all, when I t-chart this right here, remember how I told you b over 2 is what you get before you square it? So this is x plus 9 over 4 squared. And then to complete this math right here, which is negative 7 plus 81 over 16, I just need common denominators. Now I know you're probably thinking like, oh, I can't believe we're having to do this. It's this kind of math right here that you have to be, you don't have to like it, but you have to be able to do it. Not with a smile on your face, but kind of without complaining, because this is embedded in so many other types of problems in math. So if this isn't your thing, this might not be your class for you, or you might just have to suck it up, buttercup. So when we do this, how am I getting negative 112? It's because I'm going times 16, and that gives me that. So I have x plus 9 over 4 squared equals, combine like terms, and I get negative 31 over 16. Well, remember, I'm trying to solve for x, so I have to square root both sides. Now, I see a negative under the denominator, imaginary. Yep, it's all coming. But first, let's just take it piece by piece. So first of all, this is going to be plus or minus, and we learned way back in P1 or P2 that it's okay to do this. And in this case, it's advantageous for us to do that, because if we take the square root of 16, it's 4, and we don't have to rationalize, which is nice. And then also, remember, when you have a negative, that's like 31 times negative 1, and negative 1, or sorry, the square root of negative 1 equals I. I'm just going to take that little equal sign out there because I don't want to confuse people. So that's what we have. So we get x equals negative 9/4. So I'm solving for x, so I'm moving the 9/4 over, plus or minus I root 31 over 4. You're more than welcome to put the I on the other side of the square root of 31. Just make sure it's very clear that it's not underneath the radical. Or we could also write this as negative 9 plus or minus I root 31 over 4. So this is split up into two fractions, and that's into one. Okay, so that's our answer for that big completing the square problem. But keep in mind, that's like an honors level problem right there, so I'll even put a tricky on it. You should be able to follow that from start to finish. Flip it over. So this one is where we actually just practice the fallback way of solving any quadratic, which is by quadratic formula. So here's my little ABC chart. First thing you're going to do is make sure it equals 0 on one side, and then this is your A, your B, and your C. So 2 to negative 1. You can sing this song if you want. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So that all over is important because it's from the negative 2 all the way over. So then we get X equals negative 2 plus or minus the square root. Simplify when in here. 2 squared is 4. And then a negative and a negative, that's going to be plus 8 all over 4. And we get X equals negative 2 plus or minus the square root of 12 all over 4. And then this is not simplified, so that's 4 times 3. So that's X equals negative 2 plus or minus 2 root 3 over 4. And then there's two ways to simplify this depending on your preference. But first you could break it into two fractions. So this and this can simplify. So that would be negative 1/2 plus or minus root 3 over 2, which is a good answer. Or what you can do is factor out a negative 2. Now keep in mind when you factor out a negative 2, what's really happening is this is switching. But really, does that matter because it's still going to be plus or minus? And then we have root 3. Whoops, I didn't factor that out. Yikesies. So what this actually looks like is we're going to get 1 because the negative 2 times 1 is negative 2. And then root 3. And again, when I write my answer, I'm going to switch those back. But you can see when I factor out the negative 2 from that, the positive one goes to negative and the negative one goes to positive all over 4, and then these reduce right here. So I end up with, again, it's going to be negative 1 plus or minus root 3 over 2. So there's your two answers. Neither one is more correct than the other. They're both completely simplified. One's written as terms and one's written as a combined fraction. Okay, moving on. Example 7. So we've done rationals, absolute value, quadratics, and now we're doing radicals. So whenever you have the radicals, the first thing you're going to know is you're going to have to check for extraneous solutions because you're going to be squaring something. And anytime you square something that wasn't originally squared, you could be creating false answers. So what you're going to do first is isolate the absolute value. If there's two absolute values, it's usually a good idea to get one on one side and one on the other. Then your next step is to square both sides and make sure that no puppies die in this problem. So x squared plus 12x plus 36 when you FOIL that, not x squared plus 36, which is a common math mistake. And then what you're going to have is you're going to go, it's quadratic, so you want to get one side equal to 0. I prefer to have my x squared term be positive, so instead of subtracting all this to the left side, I'm going to subtract this to the right side and then put my equal 0 on the other side. So x squared plus 10x plus 21 equals 0. I could complete the square here because this is an even, there's no leading coefficient, but in my brain right away I see that I can factor this, so I'm going to. So I get x equals -7 and -3, and then I need to check my answer. So I'm actually just going to do a mental check, kind of. Well, I'll show it to you just to be clear. So I'm taking these answers, and you have to plug it back into the original problem. So 2 times -7 plus 15 minus 6, does that equal -7? So I've just plugged the x in, and this is right here. I don't want this to go too far. -14 plus 15 is 1. Square root of 1 is 1. 1 minus 6 does not equal -7. So that's not a valid solution. You do want to check your other one because they both can be invalid. So on this one, I get the square root of 9 minus 6. Does that equal -3? So I get 3 minus 6. Does that equal -3? -3 equals -3. So my only valid solution is x equals -3. Woohoo! Final problem. This one will be on your test. Make sure you know how to do these word problems. You guys don't like word problems typically. Maybe not you, but in the past students haven't liked these word problems. They're not that difficult. You just got to really pay attention to the wording, because the wording they change up the situations essentially. So a rectangular garden measuring 16 by 12 feet. So here's my rectangular garden. I'm going to shade it in green just so you can see the garden part. I don't know if that's coming up green, but it's a green pen. So there's my rectangular garden. Only that inner rectangle is the garden. Whoever's making this garden wants to add a nice little path all the way around it to surround the entire garden. The artist doing the work wants the garden and the path to cover 320 square feet. So I know it's area because it says area, but because it's square feet, that makes it area as well. So 320 feet squared is what he has to work with for the whole thing. Now we know part of it is 12 times 16, but what they want to know is how wide should he make the path. So when they say a path of uniform width, it's like a picture frame. It means like it's even all the way around. So even though we don't know the width of the path, what we do know is it's the same dimension. So if one side is 2 feet, they're all 2 feet, etc. So the area that we have is for the whole thing. So what's really cool is using just our math skills, we can figure out what this dimension is, because really that dimension is the same as that dimension right there, and that'll give you one of the sides. So that particular dimension is x plus the 16 plus the other side of the x. So that dimension all boils down to 2x plus 16. And then we can do the same thing. We need to know this dimension right here, which is the same as this, and area equals length times width, which is why I need those dimensions right there. So what is that one? It's going to be x plus 12 plus x, which all boils down to 2x plus 12. So what I know now is 2x plus 12 times 2x plus 16 equals 320 feet squared. I have had students in the past who do change this up a little bit to figure it out. So this isn't the only way, this is just the most common way to do it. So moving on, what I'm going to do now is notice that within each of my factors I have a common factor. So I'm going to pull out this 2 because in the end I can already see it's going to be quadratic, and I want to make my life easier. And the way that I can do that is by pulling out my common factors. The commutative property of math tells me I can rearrange my factors if I am indeed multiplying, which is what factors are. So 2 and 2 makes 4, and then I still have these other factors here. And then I can even do this and divide out that common factor. And then I'm going to FOIL this, so I get x squared plus 14x plus 48 equals 80. And then because it's quadratic, I'm going to subtract. And then if I can FOIL, I FOIL, and if I can't FOIL, then I would quadratic formula or complete the square. And again, completing the square wouldn't be so bad with this one because it's a 14 and b over 2 squared would be easy. But once again, this particular problem, 16 and 2 make negative 32. I should say 16 and negative 2. So I get x equals negative 16 and 2. However, negative 16 is a good solution if I just asked you to solve this equation. But because it's got a context, negative 16 feet does not make sense. So based upon the context of the problem, you determine whether or not to include solutions. So I'm not including this solution because it doesn't make sense in the context of the problem. So I get 2 feet. And that is all we have for today.